So hello guys, today's topic is steady flow energy equation. So we all know what is a steady flow process. Steady flow means that the rate of flow of mass and energy across the control surface are constant. So let's take a steady flow device. This is a steady flow device. This is the inlet valve and this is the outlet valve. Flow in, flow out. This is ground surface. So the inlet valve is about Z1 height and the outlet valve is at about Z2. So V1 is the velocity at inlet, V2 is the velocity at outlet, A1 is the cross section, A2 is the cross section at outlet, and W1 is the mass flow rate, W2 is the mass flow rate at outlet, P1 is pressure, P2, and U1 is the internal energy at inlet and U2 is the internal energy at outlet. So here dq by dt is the net rate of heat transfer to the control surface, and dw by dt is the net rate of work transfer. So here comes the steady flow energy equation. H1 plus V1 square by 2 plus Z1G plus dq by dm equal to H2 plus V2 square by 2 plus Z2G plus dw by dm. So this equation represents the energy flow per unit mass of fluid. We can also represent this equation for energy flow per unit time, that is W1 of H1 plus V1 square by 2 plus Z1G plus dq by dt equal to W2 H2 plus V2 square by 2 plus Z2G plus dwx by dt. So these two are the steady flow energy equations. So this equation, the energy flow per unit mass, is usually more convenient when only a single stream of fluid enters and leaves the control. Whereas more than one fluid stream is involved, the basis of energy flow per unit time is more convenient, means this equation. So now let's discuss some of the applications of steady flow energy equation. So the first one is nozzle and diffuser. So nozzle and diffuser. Nozzle is nothing but is a device which increases the velocity or kinetic energy of a fluid at the expense of its pressure drop, whereas diffuser increases the pressure of the fluid at the expense of its kinetic energy. So for a nozzle, the dq by dm equal to 0, dwx by dm equal to 0, and the change in potential energy, that is Z2G minus Z1G equal to 0. So the steady flow energy equation becomes H1 plus V1 square by 2 equal to H2 plus V2 square by 2. This is for both nozzle and diffuser. So whenever the inlet velocity, that is the velocity of approach V1, is comparatively very small, then V1 becomes 0. Then the equation becomes H1 equal to H2 plus V2 square by 2. V2 equal to root over 2 H1 minus H2. So the next application is throttling device. So when a fluid flows through a constricted passage like a partially opened valve or an orifice or a porous plug, there is an appreciable drop in pressure. Then the flow is said to be throttled. So basically, throttling device is nothing but is a device which decreases the pressure. So there will be a pressure drop. So for a throttling device, the dq by dm will be 0 and dwx by dm will also be 0. So the change in potential energy are very small and can be ignored. So steady flow energy equation becomes same as in case of nozzle and diffuser, h1 by h1 plus v1 square by 2 equal to h2 plus v2 square by 2. In this case, the pipe velocities in throttling are so low that the kinetic energy terms can also be neglected. Means v1 square and v2 square by 2 can be neglected. So h1 equal to h2. So the enthalpy of the fluid before throttling is equal to the enthalpy of the fluid after throttling. So the third application, turbines and compressor. So turbines and engines give positive power output, whereas compressors and pumps require power input. So for a turbine, let us say, which is well insulated, the flow velocities are very often small and the kinetic energy terms can also be neglected. So for turbine, the steady flow energy equation becomes h1 equal to h2 plus dwx by dm. But for a compressor, this is for turbine, and for compressor the energy equation becomes, so in case of turbine it gives positive power output, but in case of compressors it requires power input. So h1 equal to h2 minus dwx by dm. So these are the some of the applications based on a steady flow energy equation. So in the next video we can see numericals based on S.F.E.E.